Hello and welcome to our webinar about the challenges and solutions for the distribution grid of tomorrow. My name is Oliver Deutschle. I'm Managing Director of SMIGHT, and I have some relevant experience in power grids. I worked for over 20 years for large grid operators in the protection department, in the network planning department, and I was head of the operations department. And today I bring with the SMIGHT team smart grid solutions to grid operators all over Europe. And with me is Dirk.
Right, I'm Dirk Tahar. I'm our International Business Development Manager, and I'm responsible for bringing SMIGHT out beyond the borders of Germany to the rest of the world. And that's why we want to bring you this English presentation today. So we're going to be covering three main topics today. First of all, we really want to depict the challenge faced by grid operators in the energy transition. Then we want to show why we think that smart grids are the way that we need to solve that solution, and how SMIGHT can provide a smart grid solution for the low voltage networks that we have out there in the world today. So to start off with, we want to really get across this idea of what is the challenge, what's the nature of the problem that grid operators are facing today. And so we're going to do that with a couple of stories, one telling you how the future could look if we don't act now, and one showing if we do act now in the right ways, how things can turn out really quite okay. So Ollie's going to kick off with one of our first stories.
Yeah, and this story was told by a CEO of a large network, of a German network operator, and he told me he has trouble sleeping at night because he imagines the following scene. He is worried that the energy transition will put a very heavy burden on his grid very quickly, and he's afraid that a fuse will blow somewhere, and he knows if it happens, he has no idea where the next fuse will blow, and he has acted too late. And he told me this story you see here on the screen. A grid worker enters a substation early in the morning. It's still dark outside, and he does some inspection in the station. So he checks the fuses with his torch. Suddenly, there is a loud bang, and the lights go out. The worker is scared and falls and drops his lamp, and he steps out into the street and looks down the street, and everything is dark. People come out of their houses with the light of their cell phone cameras, and the crowd of people is approaching him. So this CEO, he replied to me, if this scene would actually occur, what he would do. And he said, you can't just push the fuse back in, because first you have to know the cause, then reduce the load on the customer side, then put the fuse back in, and then finally make sure that customers no longer receive high load at the same time. But that will not work in practice. So he has to make sure that his company does not get in touch such a bad situation.
I'm sure any TSO watching today can sympathize with that scenario, this idea that the energy transition hits your network in some critical form, and then you're just left firefighting, having to deal with very difficult issues. So now let's look at how an alternative scenario could look. So here I want you to imagine it's a few years in the future. It's February 2026. The Winter Olympics are happening in northern Italy, and a few things are coming together at one time. First of all, the ice hockey league that's happening in the Winter Olympics, the Italian team has got through to the final, and they're the underdogs. It's been full of controversy all the way through the Olympics until now. It's captured the nation's imagination, and everybody's going to be watching the game tonight. A huge cold weather front has also swept across Europe. And at the same time, over the last few years, the Green parties in many countries have made massive progress on rolling out EV charging, heat pumps, and so on. And so we have this perfect storm situation. We're going to have the heat pumps running at full blast. We're going to have people coming home at the same time with their EVs charging. And everybody's going to be at home consuming power, cooking the kettle or whatever they're doing. And with all of that comes this massive peak load. And so our fictitious character here wants to go out to the substation and see what happens. So he goes out to the substation. It's about half an hour before the game. He opens the door and he walks in. And he knows out there the loads are steadily increasing. And so what does he do? He stands and he listens. And what does he hear? He hears absolutely nothing. Just the comforting hum of the transformer doing its job. What he can't hear, and what's actually happening in the background, is the SMIGHT sensors have recognized the load increase and sent a signal out to all the loads on the network. And all those loads are reducing down to a level where they're still usable. So the heat pumps are still producing heat, but just not at full power. The EV chargers are charging, just not at full power. And all the lights stay on. Everybody can watch the match. Everybody is happy. And so our character can come out of the substation feeling very happy that they took the right actions early enough. These are two rather fictitious scenarios, but I think we get the message across. If we wait too late in the energy transition and act too late, we really are in a very difficult situation. Whereas if we act now, we can stay ahead of the energy transition and ensure that we have stable grids.
Okay, perfect. Thank you very much, Dirk, that things can end positive.
Yeah.
But where are we headed in general? Which great dilemma do we face?
Yeah. So as we see it, grids are really facing a very difficult dilemma. On the one side, society requires of them that they enable the energy transition. But on the other side, society also requires that grids remain stable, that we have power. We can just flip a switch at any time and have the power that we need. And these two things are in conflict because without the energy, if the energy transition is too fast, grid stability will go down. And likewise, if we prioritize grid stability, the energy transition won't happen. And so society requires that the grid operators maintain this balancing act. And it is a difficult balancing act.
Okay, and what do grid operators do to face this dilemma?
Okay, so now we want to look at what's the possible direction of the solution. What could they possibly do? Now, traditionally, the grid operators would address loads by building network, in effect, reinforcement, building new cables, new transformers, and so on. That's one approach. But let's just have a look at the size of the problem. So if we take here our balancing scales that we had before, and we take those green balls on the one side for the energy transition, what those figures were in 2021. These are figures from Germany. So if we say these are the installations of solar, of EV chargers and heat pumps. Now let's play forward into 2030 and see how those grow. So you can see already a large growth in solar panel installations. And we have to bear in mind that Germany has been quite at the forefront of solar power installations. So this is still some pretty strong growth. Heat pumps are set to grow as well. And again, in comparison to quite a few countries, Germany has been quite at the forefront. But the huge one here, we couldn't even fit it onto the slide, is how much EV charging is going to grow. And this is just in number of installations. This doesn't even take into account the size of the loads. The loads that are required for EV charging are really very, very big. So we have this one side of the balancing scales where we're going to be adding some extremely heavy weights. So what does the other side look like? If we took the investment in Germany alone into the distribution network alone, so not looking at the transmission level, in 2014, so before the energy transition really got going, we were spending about 3 billion euros a year. Let's wind that forward to today. That has already doubled to about 7 billion euros a year. Now let's play forward. What would be required to meet this demand in the future? You can see by the size of the circle, this is a huge jump to about 20 billion a year. Not 20 billion one-off, 20 billion a year just to keep up. We really believe that this rate of growth, and it's not just us, it's other industry professionals, is just simply not possible on various different levels. We, as a society, can't afford to spend that much on our grids. We don't have the supply chain capacity to be able to deliver all of the hardware that's required that. We don't have the manpower to do all of that. All those factors, it's just too much growth too quickly to be able to manage it.
So you said reinforcement is not the solution. What is the solution?
Okay, so we believe the middle ground is smart grids. And to be honest, it's not just us who believe this. This is generally being put out there. We need to manage this transition through the use of smart grids.
And what do you mean? What is a smart grid?
Yeah. So for us, smart grids really are two factors. On the one side, they're self-aware, and on the other side, they're self-controlling. So by self-aware, we mean needing to deploy sensors out into the grid so that the networks know what's happening. And at the moment, you have to imagine at higher and medium voltage levels, there's a reasonable amount of transparency as to what energy flows are flowing. But then at the low voltage level, it's more or less a black box in most places in the world. And it's there where most of the energy transition is happening. And that's where we need to bring transparency. So we've got the self-aware side, but then we have the control side. Now, again, if we take the higher level voltage levels, you have a control system, you have people who can oversee that. And that's because the numbers there are so much easier to deal with. Just as a comparison, a typical relatively large network might have somewhere between 100 and 200 primary substations, whereas that same network on the low voltage level would have tens of thousands of secondary substations. You simply cannot manage that number of points and loads and the dynamic that comes with that through people sitting in a control room. You need a system which controls that. And that's where we mean that it is self-controlling. The system needs to be able to understand what's happening and be able to send control signals automatically to manage and balance the loads across the network. That is what a smart grid is.
Okay, perfect. So a self-aware and a self-controlling grid. But how does this smart grid helps DSO to balance this great dilemma you have showed?
Exactly. So on the one hand, it's going to help us achieve the energy transition, but it also has some advantages for the actual DSOs themselves. So the first level that we have is prioritization. So right at the moment, without knowing any information about the low voltage network, how does a DSO decide where and when to do what in terms of reinforcement work? And any smart grid solution should be able to provide to the DSO the overview and the information needed to know which transformers, which cables, which switching actions, which reinforcement works need to be done where and when, looking forward into the future. So to be able to prioritize the work to do the right things first. The next level is utilization. So we're all aware that in the network, you're not going to have an equal loading across all feeders and all substations. There's going to be differences. So there's going to be underutilization in some areas and high utilization in other areas. And so we brought this example here from one of our customers using our solution at the moment, where in the top right, you can see a situation on a feeder where the load was consistently beyond the fuse limit. So we have these little dots you can probably see on the slide at the top, showing where that fuse limit was being gone over. They were then able to make a switching action in their topology, which then moved that load through to another feeder. So this is a perfect situation. You've got existing infrastructure and you're able to use it better and therefore not have to invest. And so the more insights we can generate to enable utilization, the less money needs to be spent on networks. The next one is optimization. So in low voltage networks, the topic of neutral line loads is quite a big one. And this is caused by asymmetry in the phases. Now this can happen through a number of reasons, but something that's coming with the energy transition is EV charging. Whilst EV chargers quite often are installed across all three phases, they don't charge equally across those phases. And we see this again and again, that at the beginning of the charge process, maybe all three phases are being used, but then steadily as the charge process progresses, it switches over to one or two of the phases. And this causes quite big asymmetries. And if you multiply that out, so let's say all the EV chargers on a given street are installed in the same configuration, and everybody comes back at the same time and has the same situation, you can imagine the size of the neutral line loads. And there are other causes out there. But for the DSO to be able to identify where this is happening, build it into calculations, and also to possibly take actions to reduce those loads will create a much more efficient network. And then finally, we have strategize. So by being able to take the data that we're providing DSOs, they're able to then plan better for the future. With more accurate data, we're going to make better decisions. So we brought an example here from Düsseldorf, where they were wanting to deploy further heat pumps out into a particular area of their network. And they had their simulation tool, which had predicted where and to what extent they could roll out these heat pumps. And they then wanted to use our data to validate whether that simulation was correct. In the table in the top right that you can see here, the gray lines show where the simulation and the real world measurements that we were taking were quite accurate. However, you can see two feeders, number 4 and 7, were quite far out. So we had 50% in one direction and about 60% in the other direction. And so by being able to take that data, you're able to correct the models and make better decisions. I mean, imagine in this scenario, you'd underestimated what the load was, deployed the heat pumps, and then had to reinforce the network as a result. Would that have been the right decision? But with real world data, those decisions can be made much better.
Okay, perfect. Thank you very much for these impressive examples. So we discuss which approach SMIGHT has. So you said it's important to phase the energy transition very fast. What is a SMIGHT approach by bringing devices, equipment, data very fast in the grid?
Exactly. So let's have a look at SMIGHT's solution to creating smart grids to enable the energy transition. So Ollie, through his experience within the DSO background, can give me a few inputs here as to what are the requirements from a DSO side that we have to meet with our solution.
The first thing is, as I said, bringing out very fast. So we don't have too much time to bring complex solutions in the grid. So It must be fast.
Yeah. So the energy transition requires speed, but also the size of the network requires speed. Again, bearing in mind that the low voltage networks are huge, and therefore we need to be able to roll out quickly. So we've focused our efforts on creating a retrofittable solution. So it can go out into all of the infrastructure that's already out there. We don't need to be swapping out anything, creating intelligent substations or anything like that. You can use all the infrastructure you have there. We can just make it smart, very simply and very fast.
And we have to limit the disruption. We cannot cut off whole of the grid.
Exactly. So we need a solution which can be installed whilst the system is running. And that's precisely what our solution does. You can install it while all the power is on. No one needs to be cut off. There's absolutely no disruption.
And it has to be done very easily. So everybody should be able to install devices.
Exactly. The DSOs don't have the resources to be training up a specialist team to be able to do this. So we've really placed an emphasis on making sure that the technicians who are working out in the networks already can install our solution extremely fast, but without any specialist training. This can be done by anyone, and we're going to show you that in a moment.
And as a grid operator, we are afraid about big and complex and expensive IT projects. So it should be a very easy solution on the IT side also.
Yeah, so we recognize that DSOs have got a lot on their plate, and we want to take some of that away. So the solution that we provide is completely end-to-end. We deal with all of the IT back-end, so there's no big IT project to take all this new data that you're collecting from your network and being able to do all the storage, the processing, and so on with that. We deal with all of that. We just deliver the full solution that is quick and easy and fast to install.
Okay, perfect. So let's go one level deeper. Could you show us this installation process?
Yeah, let's have a look at how this works in practice. So this first of all starts back at the office. So what our customers do is they use our device admin to lay out all of their network in the system. So they lay down which substations they're going to be measuring, the feeder information in there, the fuse ratings, the users. They can lay down all kinds of information which is useful for understanding the network. They do all that in a web-based backend. So there's no specialist software that needs to be kept up to date or run on servers or anything like that. It's all done through a web platform. Once that's been done, the technicians can then take our devices out and install them out in the substations and distribution cabinets. This is extremely simple, and we'll show you that in a moment. But through a very simple process with a QR code and a phone application, we're then connecting the data that was set up in the back end to the installation out in the field. And so with this, within 15 minutes, we have the live data available to the DSO. So it really is that quick. The limiting factor is how quickly you can get around your network. So let's move over into our live demonstration. Okay, so what we've got here is just an example of what a feeder might look like, just for demonstration purposes. And so this is our standard sensor that we have here. This is the piece that we call the sensor. And then these are the split core current transformers which are installed on the cables. And so we label all of these up with which phase they should be on. And we also have the direction that they should be installed. And so all the installer is doing is taking these and clipping them round onto the cables like this. So this can be done with the kind of gloves that they need to wearing with all of the other safety equipment. It's a little bit easier for me here with all this space.
It's even easy for you. You're not an expert for such things, but if you do it wrong, so take the wrong phase, or what is happening? Yeah.
So it could easily happen that, as Ollie says, we could have the wrong phase. I could also install these in the wrong direction, and therefore the flow would be incorrect. That's not a problem. So 90% of those cases, in the back end of the system, we can first of all identify that and correct it very quickly and simply. We can also identify it and communicate that out to the DSO. That's very simple.
And this can be done live, or you have to cut off the station?
Exactly. So all of this is being done live, and yeah, it's very simple.
On the sensor side, we don't see any installation cable. How does it work?
Yeah, so there's no power cable here, but what they're doing, these devices are energy harvesting. So they're taking the measurements and collecting the energy and supplying that back to the sensor. And then the sensor is transmitting the measurement data to our gateway, and that's then transmitting it out into the cloud. And the advantage of that means that the connection between the sensor and the gateway being wireless means there's no cables being run through the substation or the cabinet, not getting in the way. So imagine that scenario where you're having to go out and do something urgently within the substation and you've got cables everywhere. That would be a real problem. And so we've dealt with that through the wireless communication.
But this is a little bit unfair because it's a much space between the phases. So we prepared another thing. Could you show the same installation in the cabinet?
Yeah. So not only is this a little bit unfair for demonstration purposes, in the real world out there, we don't always have plenty of space to be able to work with. And in addition, we don't always have cables that are this thin. They're sometimes much larger cables. And so we have a second solution. This is what we call our sensor flex. And this solution uses Rogowski coils, which can be used for much larger diameters. And also this can be used in much tighter situations. So I've brought with us a distribution cabinet, a typical one that you'd find here in Germany, where the situation down in the bottom here is generally much tighter. The cables are closer together. This is usually underground, and it's much more difficult to install. So just like with our other sensors, we label them all up with which phase they should go onto. We also have the direction of the flow. And just as with the other ones, if any of that's done incorrectly, we can correct that in the back end of the system. So I'm just going to lay that inside for the moment.
So you need assistance, or is it, can it be done by one worker?
It should be able to be done by one worker. As long as they can do this clicking action, which is fairly simple, they should have no problem installing this. And this is not just in theory. I mean, all of our customers at the moment are out there installing these without any issues. And we have fantastic feedback, which we always collect from the customers as to how easy it is for them.
How many sensors are already installed out there?
So we have in the region of 4,000 gateways, and then sensors on top of that. We're measuring about 100,000 measurement points at the moment out in the
You said gateway, so how is the connection between the sensor and the gateway we say at the door?
Yeah, so as I said before, we have a Bluetooth connection. So the sensor here, this is collecting the measurement information from the cables directly, and this is sending via Bluetooth up to the gateway, and the gateway is sending that up into the cloud.
And you said it's our Rogowski coils.
Yep.
So how is the connections to a power supply in that case?
Yeah, so that's the one downside of Rogowski coils, is that they can't do the energy harvesting. So we've already put in here a power supply, and we work with a company who has these special connections, which means that you don't need to put a socket in. You can connect into the infrastructure very simply within the installation situation. And you can even reinstall all the covers here back onto the devices. And we also deliver the tools required to do that. So the power supply is then connected onto the sensors, and the sensors in turn are connected to one another via a daisy chain. And one can also install a mixture of sensors. So if you had an area which was tighter, you could install some flex sensors, and an area that is a bit more open, you could install the standard sensors. And we can install up to 20 sensors per gateway. And if you needed more than that, you'd simply install 2 gateways.
Okay, looks very simple for installation. So how is about the deinstallation process if I like to change?
So this is a situation that we see out in the market, is that sometimes you pick out a substation or distribution cabinet, you perform the installation, and then you find out the loads are just really uninteresting. They're particularly low, they're in line with what you expect, and therefore monitoring it on a continual basis maybe doesn't make sense. And so what I've just done, you can do in reverse. You can undo all the coils, you can take the gateway out, and you can take that to another station and install it there. And again, through the same process with the QR codes and the device admin in the background, you can then move that device somewhere else in your system, therefore enabling you to work your way through your network. And we don't advise people move things around all the time because you lose the trend of data over time. But if you find an area which is uninteresting, there's no point in measuring it. Just keep moving through your network, find the critical points and measure those.
Okay, perfect. So you have already explained what is happening if the worker does the installation on the wrong way, if the current transformer is done on the fault side, or something is done wrong. What is happening below the surface beside these aspects?
Okay, so it's very obvious to see here what's going on with the physical items. Now we'll just flip back to our system here to show you what's going on beneath the hood. So on the one side, we've got all the data transmission. So we're managing the data flows from the sensors to the gateways and the gateways into the cloud. We're also then managing all of that data storage and all that data backup, and at the same time having to deal with all of the data security issues. So we use a cloud platform which is ISO 27001 certified, so that your data is always secure. On the other side, we're doing all the administrative work. So we're making sure that all the devices are installed correctly and are operating correctly. So we can have a very simple situation. Maybe someone works in a substation and pulls the plug out from the gateway and it has no power. We can identify that, alert our customer, and therefore they can easily go and correct it. So we're dealing with all those kind of things. And on top of that, we're able to roll out software updates and patches very easily to the whole fleet of devices. I think to appreciate how important that is, imagine doing this all yourself. So imagine you've got a network of maybe 10,000 substations. You want to roll it out to 20%. How many gateways is that? How many feeders is that with sensors? Each one of those is a mini computer out there which needs to be monitored and needs to be kept up to date. And you need the infrastructure in place to be able to do that. And we offer that all as part of our package, so you don't need to worry about that. That's what we mean by no need for a big IT project to be able to deliver this. We deliver that all. So that's what's happening below the surface. We're keeping an eye on the back end and making sure that everything runs smoothly. But then we deliver the data out into the world. So on the one side, we have our SMIGHT IQ, which we're going to look at in a moment, where we visualize and make the data useful for you. But we also play nicely with others. So our platform can be used via an API to deliver data out to things like flexibility platforms, where, for instance, where you can see where peaks are, exactly where they're happening, when they're happening, and to what extent. That can help enable flexibility to be deployed out in the low voltage network. As we gave the example before with Düsseldorf, you can use the data to validate and sharpen the simulation tools. You could use it in control systems and also in digital twin packages, which are often being used today. So all that data is going out into the world. Let's have a look now at the platform.
Okay, perfect. So you have explained how we can easily install the sensors, how we do the management of the devices, how we can transmit the data, and now let's have a deeper look how we can make this data useful with SMIGHT IQ Cockpit.
Exactly. So I'm inside the cockpit here. This is all web-based. As we said before, there's no need for specialist software. You can log in through any computer that's connected to the internet and access your data. Now, the data that we're going to show you here is real data that we've taken from customers, and we've anonymized it and put it into a map around where our office is. And so what you'd first see when you log in is this very much a helicopter view. And with that, you can then identify where there are critical points in your network. So we use a traffic light system, fairly simple. With any given feeder below 60%, the pin for the substation would show as green. Between 60 and 80% it shows as yellow, and anything above 80% is showing as red. We also give a very quick overview of any given feeder that has been a high load. So again, you can quickly from the home page zoom right into the critical points. And we also record the critical events where the threshold has been violated, so where that fuse rating has been gone over. So once again, you can go into a single point in time very quickly from the dashboard.
So what could I do if a pin is red?
Yeah, so let's take one of these red pins that we have on the map here. So I can click into that. It gives me some summary information about the substation. Again, you as the customer are free to label these however makes sense for you, whether that's matching your GIS information or whether you want to label it in some way that makes more sense. That's fine. You can then click into the substation and then you see this summary view of the substation data. And so this again can be played with according to what you need, whether it's looking at different phases, whether it's looking at reactive or active current. You can look at voltage in there as well. And we show all of this information. And just to reiterate, this is live data. The speed with which this system works is exactly the same speed that you would be seeing out there. Now, in our example, we had a red pin, but that's only related to one particular feeder. So I can go one level deeper. So I can click in here to this feeder, and then I can see a series of data here. So I'm going to put back in the main phases here. I'm going to take out the active currents. So again, you can play with this to your heart's content, and we're also going to leave a link to our demo at the end of the webinar, and you can go in and play with this on our website live and see all of how this is working. What we also enable doing is zooming in time-wise. So what I can do is highlight a particular period and it zooms in. Again, maybe I want to look more at what's happening here. And depending on your needs, you can then play around. And this was the example that we had in our slides earlier, where the customer had particularly high loads and was then able to take a switching action to then pull them back down again.
What are the signs, the yellow and the red signs?
So these are the warning symbols. So we have yellow ones when the kind of minimum threshold is gone over, and we usually set that at 20% below the fuse rating, and the red ones are where the fuse rating has been gone over.
Can I receive an alert?
Yeah, so we have our system set up to send out emails to the addresses that you require as and when these events happen. So you can immediately see a summary, and we also send out a monthly report. So again, you can get this overview of what happened last month where.
And if I have such a situation, what could I do as a grid operator?
So in this particular situation, I can identify here in particular that it's one particular phase which is causing the issue. So I could then maybe go and look in my data and try and see what's connected there and what might I be able to do about it. But what this particular customer did is they went out and did the switching action to take the load and put it onto another feeder.
Okay, perfect. So this is a overloaded feeder, and they did some switching and put the load from this feeder to another feeder, and they reduced the load on this specific problem feeder.
Yep.
What's about PV? It's a big issue, not just in Germany. How can I see how PV has an impact on my grid?
Yeah. And so one of the features of the SMIGHT system is being able to see the flow direction, and that's quite important, especially for solar panel installations. So we have a particular example in here to show what this looks like. So it's this one, and I'm going to go into this feeder here. Now, on first look, it looks really uninteresting, and that's because I'm in the winter months at the moment. So I've always got to bear in mind the time window. So I'm going to go and zoom out to a whole year's worth of data. And again, imagine what a whole year's worth of data really means, taking once a minute measurements across 3 phases, plus the neutral line, phase angle, and all of this information being represented in real time this fast. I think for our guys who developed this, it really is quite an achievement. And again, we can start to see through the relative currents here, which I can bring back in. I can take the loads away. You can see the negative flow. So here I can see my 0 line, and then down here I can see the negative flows. In this particular case, it wasn't critical, but it gives you an idea that we can visualize that. And in some cases, especially on particularly long feeders where you have a lot of solar installations, you can really have a much bigger issue. And so being able to identify those and which direction it's flowing in really is quite important.
Okay, perfect. So you said a smart grid is self-aware and a self-controlling grid, and you have shown in the last couple of minutes how we can bring devices out there, how we can bring hardware out there, and now you have shown us how data can be used to solve a real problem out there. But who is SMIGHT on a company level? Who is SMIGHT as a company?
Yeah, so we've been in this field of using Internet of Things sensors and all of that infrastructure for about 8 years. We're now a team of between 30 and 40 people. And as we mentioned before, we're already working with 120 DSOs around Germany and other parts of Europe. And we have got about 100,000 measuring points already out there. So again, just to really iterate that we're already doing this. This is not a nice concept that we'd like to roll out. This is something that's already in operation at a reasonable scale. It's safe, it's working. And the other thing we want to get across is that we've been working with various different sizes of customers. We can work very well with the larger ones, with their kind of requirements, but also smaller DSOs who have a different set of requirements. And we came out of the EMBW group. So we have this great combination of being a relatively small, agile and flexible company, whilst having significant backing behind us to be able to assure you that we'll be there to be able to continue to support you.
Okay, perfect. Thank you very much. So we have heard a lot. Could you give us a short summary what we have heard this morning?
Yeah. So in the outset, we wanted to really get across this idea of what is the problem faced by network operators. And this problem is this dilemma between two good things that they both need to achieve. And society kind of requires this of them. On the one side, the energy transition needs to happen. On the other side, we need reliable, stable grids. And the network operators somehow need to achieve this. We believe that simply by doing the old technique of reinforcement and building of networks, even if we wanted to, we just couldn't do it. And therefore, we need to implement smart grids. And this in particular needs to be done on the low voltage. A, because it's not been done there already. And B, most of the energy transition happens on the low voltage grid. This is where the dynamic is being introduced. And that's where we need to bring in the measurements. And we believe we have a solution with SMIGHT that is quick to roll out in retrofit, is very simple to use, and is very effective at bringing that transparency into low voltage networks. And it's one that can be deployed today at scale without any difficulty.
Okay, perfect. And if I'm interested in this solution, how can I get in touch with SMIGHT?
Okay, so we have the usual channels. You can go and view our website. We've got the links here on the slide. We have the demo, which we just went through. You can play with yourself if you're interested in looking into a little bit more detail of the data that we're capturing. We have our LinkedIn. We're happy for you to get in contact with us there. And really want to call out to all the DSOs out around the world and other companies working with DSOs to please get in contact. We're trying to roll this out beyond the borders of Germany. And we really want your help, and we want to get into contact with you so that we can support you to bring transparency into the low voltage grid. So please do get in contact.
Perfect. So thank you very much, Dirk. Thank you very much, everybody, for listening to us, and please get in touch and let us trying together bringing the energy transition and digital grids together. And we like to help you, and we would appreciate very much if you get in touch with us. Thank you very much. All the best. Bye.